Hi, everyone. This is Amanda from HashiCorp. It looks like people are still joining, but we'll go ahead and I think get started. So thank you for joining us for today's webinar hosted by our solutions engineering team. Today, we're going to discuss how the Cloud Foundry Vault Service Broker enables developers to focus solely on managing their secrets, while the service broker automatically handles authentication and security. I'd like to introduce you to our presenter today. Stenio is a senior solutions engineer at HashiCorp. Stenio is going to introduce HashiCorp Vault along with the Cloud Foundry Vault Service Broker. Stenio will then show you how to configure Vault to allow a secure and convenient workflow within PCF and how apps can interact with the Cloud Foundry HashiCorp Vault Service Broker within the PCF environment. Next, Stenio will give a demo and wrap up by answering any questions you all have. I also want to note that this webinar is recorded, and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. With that, let's go ahead and get started. I'm going to hand it over to Stenio now, and he will start.
Thank you, Emma. Okay, now I got selecting the correct screen to share.
It's going to make the screen up for us.
Where's my button? Can you see the agenda?
Yeah, I see the webinar page.
I shared the wrong screen. Here.
That is our webinar.
Yeah, I had it there, but it's fine.
Okay. And then
okay.
Slide.
Yeah, so thank you, Amanda. Thank you, everyone. I apologize that I'm going to be looking here. I got the wrong screen set up, but it should be fine. So this is the agenda, what we're going to cover today. First, I'm going to start with a background about my professional background. I'll follow up with just some context about HashiCorp. HashiCorp is the company behind Vault, so where Vault fits in the HashiCorp ecosystem. Then I'm going to give a brief overview to Vault, about Vault. If you're already knowledgeable about Vault, feel free to cover your ears, but just to make sure that everybody's in the same page, everybody has a base understanding of how to interact with Vault and what it's supposed to do. Next, I'll follow up with how an application can interact with Vault using the Spring Cloud Vault framework. So I'm going to show the benefits and some of the limitations of that approach, and I'll follow that with the Vault PCF Service Broker, which is the main objective of this webinar, and to show how the Service Broker addresses a few of those limitations. From there, I'm going to talk about the constraints. The Service Broker doesn't do everything, so just to clarify what is the responsibility of the Service Broker versus what's the responsibility of the app. And then I'll move on to the demo. So this is me. My name is Stenio Ferrer. I'm a senior solutions engineer at HashiCorp. Prior to HashiCorp, I was working in consulting in startups, everything IT related. And I started my career as a software developer, a Java software developer. And in my spare time, I'm an aspiring rock star. So I play guitar and I sing in a band here in Chicago. So let's talk about HashiCorp. HashiCorp is a company that was founded in 2012 by Michio Hashimoto and Armon Dadgar. And the mission of HashiCorp is very simple. We enable organizations to provision, secure, connect, and run any infrastructure for any application. So each one of these capitalized words, the provision, secure, connect, and run, represents one of our products. And the products are below there. The top four they are all open source. The top four, we provide enterprise versions, and the bottom two is just the open source version. So very briefly, one sentence about each one of these products. Terraform allows an operator to describe infrastructure as code. So if you want to deploy a server, a network, IP address, you will describe all of this. So you will be able to version control, easily share, and automate your provisioning, your infrastructure provisioning. Next, there's Vault. Vault is the secure solution to manage secrets and encryption-related services. Then we have Console. Console is a service discovery tool. So service discovery you can think of as a yellow pages for apps. It's a central repository where distributed applications can find each other. Next, there's Nomad. Nomad is HashiCorp's orchestrator. For those not familiar with orchestrator, the concept is whenever you have more applications to deploy than you have resources. So you need to have something that will deploy these applications in the most optimal way. That's when you use an orchestrator. And then on the open source, we have Vagrant. Vagrant has some similarities to Terraform in the sense that you're going to describe an infrastructure, but that's in a virtual machine context. And it plugs in with VMware and VirtualBox and different providers. And finally, there's Packer. Packer is HashiCorp's tool to create machine images to help make provisioning faster and more stable and consistent. So let's talk about Vault. Every HashiCorp tool has three main use cases that are clearly defined of what kind of problem sets they're trying to resolve. For Vault, the first one is identity access management for secrets. So through Vault, you're able to specify ACL policies, identifying which entities you are going to allow to access which secrets or which encryption services inside Vault. Next, another use case for Vault is centralized secrets management. So in an organization, traditionally you would see secrets spread all over in different applications, different frameworks. So Vault provides a unified management repository for those secrets that when you're thinking about security from an enterprise level, that's helps address any security breaches. You only have one point that you need to worry about. And finally, Vault also provides encryption as a service. So instead of just storing secrets, Vault can store an encryption key that apps can use to encrypt a sensitive string. So I'm going to talk briefly about this. But this demo is going to focus on centralized secrets management. That's the most basic use case for Vault. We're going to store a static secret using key-value pairs inside Vault. So just a brief overview how an application can interact with Vault. It's a similar concept to web sessions. So if you have a client on the left and Vault on the right, the client first needs to authenticate against Vault using some sort of credentials, and Vault supports a variety of authentication methods. Once this authentication is validated on Vault, Vault is going to verify that particular entity, which kind of permissions it has access to based on the ACL policies. And based on that, Vault's going to create an access token that's returned to the app. The client then can make requests to Vault passing that access token, and Vault is going to return the secret. This communication between the client, the app, and Vault can be done through REST API calls. So every endpoint on Vault is offered as a REST API endpoint. And also there's a variety of native libraries that have been created by the community that abstract those REST API calls to a more native language base. So you can follow this link afterwards. A few examples are Go, C, Python, and one that we're going to talk about. In Java, there's the Spring Vault framework that makes this easy. So in the example that I'm going to give here, this app is being deployed within the Pivotal Cloud Foundry environment. So the app itself is using the Spring Cloud Vault to communicate with Vault. And in order to do that using that framework, it requires three main config files. The first one is traditionally in Java applications that use dependency management is the pom.xml. This is where you're going to describe your dependent libraries. Next, you have application.yaml. That's where you're going to describe which ports their app are listening, some log information, things like that. And finally, there's the Bootstrap TMO. That's where you're going to specify the vault variables, the vault address, the vault token, and what are the secret endpoints that are available for this app. So once you have all this configured, the app can just use the token that's described there and use the vault URL and requests secrets from vault. So everything works perfectly. You don't have to open sockets or worry about explicitly defining this connection. You can rely on the Spring Cloud Vault framework. Having said that, looks great, but you might ask, but how do you get the Vault token and its address? Do I have to raise a ticket and then the Vault admin has to give me this token? I go there and manually enter for each app. The other challenge is, what if I have multiple apps that I'm deploying inside my PCF environment and I want to isolate the secrets that are available across the apps? And finally, is there a way of making everything dynamic, or do I have to have this manual process every time I spin up a new app? So this is where the Vault PCF Service Broker comes into play. So you're still going to have an app that's using the Spring Cloud Vault framework being deployed on the Pivotal Cloud Foundry. But then you're going to take advantage of the PCF Service Broker model. So the Vault Service Broker is an open source project, and I'll show the code later. And what you're going to do, you are going to follow these steps. So first, assuming you have a properly configured service broker and a properly configured app, and I'll talk about this on the next slide. The first thing you need to do, you bind the service broker to the app. Once you execute this bind command, this like PCF bind, it's pretty simple. In the background, the service broker is going to communicate with Vault and create a policy, an ACL policy specific to that app. So that policy is going to give the app permission to access a certain set of secrets that I'll talk next. And then the service broker is going to generate a token associated with that policy. Once it's in possession of that token, it can inject this as a variable on Bootstrap TMO. So what before we wanted the user to manually enter here, now the service broker takes this responsibility, and once it's bound to the app, it injects this variable there. And it also injects the vault address. So the app is going to have access by default to 4 different paths inside Vault. The first 2 are shared. So one is based on an organization scope, and the next one is based on a space scope. So in PCF, there's these 2 scopes. You can have several organizations, and inside the organization you can have several spaces. And then you deploy the apps in a space. The way that this works depends on the organization. It's like allows a flexible workflow. So if you want to make the space equivalent to a department or to a project, it's going to be dependent on the organization. But from the service broker perspective, whatever is in the organization will be available as read-only for the app in this space. And then for the space, same thing, read-only. Then the app is also going to have access to its own specific path inside Vault that it can create, read, write, and update secrets. And finally, the app will have access to its own transit backend. That's the encryption key that the app can use to request to send a string to Vault, and Vault encrypts this string and returns encrypted to the app. So that's beneficial in use case where you don't want your developer to have to worry about importing encryption libraries or having to manage the rotation of the key that was used for encryption. You can delegate that work to Vault. So this, you might ask that this sounds great, but it sounds like I just shift the responsibility from configuring the Bootstrap TMO for the app to configure it to the service broker. And that is correct, but the difference is that for the service broker, you only need to do it once. And then afterwards, whenever you bind an app, it automatically is going to get populated with the correct token and the Vault URL and this dynamically generated policy. So this is going to address those 3 challenges. First, how to introduce the token and the address. Second, how to isolate the secrets. So each new bind request is going to generate a new policy. So each app will have those 4 paths, including the one that's specific to it. And finally, everything becomes dynamic. So to configure the service broker, you only need to enter the vault address and a token that's associated with a policy that gives it enough permission to create child policies and tokens associated with these policies. So I'm going to talk about this when I cover the service broker GitHub repository. So the limitations of the service broker. When I presented the service broker to a client a few weeks ago, there was a misunderstanding. They thought that the service broker could do everything and they didn't need to worry. That's not necessarily the case. So the service broker has a great it's a great convenience in the sense that it bootstraps, initializes the app with the values, but then it's the app's responsibility to communicate with Vault. The app is not going to use the service broker to request services from Vault. Second, it's outside the scope of the service broker to actually initialize any secrets inside Vault. So the service broker is only concerned about isolating, creating paths that can be isolated for each app and granting permissions to those paths. But the content, what's inside that path, is not the responsibility of the service broker. So you might ask, well, so how do I get my secrets there in the first place? It's going to depend on the workflow of your organization. One suggestion could be once the app has the token, that token, as we have seen, has read, write, create, delete permission to that specific app space. So a developer can just issue a curl command writing the secret, or it can rely on a separate app to see it, or even the app's responsibility could be to see the secret itself. Another suggestion could be to open a ticket and the Vault admin can see that secret, or a PCF admin can have greater control of the secrets that are shared across the organization. And finally, the service broker by default, if you're using the standard, what's available on GitHub, is only going to allow an app permission to access those 4 endpoints and nothing else. If you need your application to access different paths, for the example that will show database path or a more generic backend, you either are going to have to specify that by hand on the policy that was created, or you can customize the code of the service broker to add whatever path is needed. So that's the beauty of open source. So with that, we can go to the demo. This demo is actually available on HashiCorp has a GitHub repository. It's HashiCorp/Vault guides. Right now is a PR. I hope that by the end of this demo, it's going to be merged. But it's over there, everything that I'm going to show. You can look at your leisure. So, So before, I just want to show the service broker itself. There's a blog post that describes the service broker. It was created by Seth Vargo, a great contributor for HashiCorp last year. And so this gives the information overview of what I just explained, and it references the GitHub repository. So I'm going to explain the service broker to the GitHub repository. So it's HashiCorp/Vault Service Broker. And I have done this in clients before. I think it's beneficial for me to go through this README instead of me typing the commands, but then I'll show the app actually work. So what this is going to talk about is how you first deploy a service broker, assuming you have a PCF environment running. So these are all terminal commands, but I'm going to show the PCF through the UI afterwards. So first you need to export a Vault address and a Vault token. This Vault token is the token that the service broker is going to use. So that's the token that's associated with that policy that has the elevated permissions, the policy that allows it to create child policies and to associate additional to generate tokens for those policies. At the end of this, I'm going to show the policy itself, what it looks like, so you'll have a better understanding. But for now, just assume that this token is associated with a higher level policy. Then you're going to export this out username and password. So these are used for, in the PCF environment for the service broker for admin purposes. And for this demo, we're not going to use this much. So here in the example, he's deploying the service broker in a specific space inside PCF called service broker. So you create the space and you shift the target there. Then it's going to clone this repository and it's going to push this code to Cloud Foundry. Since this is a Go application, you don't need to compile or anything like that. Cloud Foundry takes responsibility of making sure everything works. They are using these two flags. Random route is in order to allow if you want additional service brokers to be deployed afterwards, if possible. And the no start is because if you were to not run this, it's going to give you an error because the service broker is not going to have the vault address and the token yet. So you do a no start. And once the service broker is available as an app inside Cloud Foundry, that's when you set the environment variables of the service broker with those environment variables you defined earlier. Once this is all done, then you can start the service broker, and if you execute this command, it's going to show that it's running. Once you do that, you want to get the service broker URL for subsequent configuration. So you're going to export as an environment variable in the terminal using this command. So this command is going to output the URL. And you can validate that everything is working as expected. If you do this curl command, it's going to show if the service broker is running, it's going to give you this success message. So the service broker is there and it's running on PCF. Now we want to bind the service broker to an app. So there's an app that's using Spring Cloud Vault, and we want this app to receive a token and to have access to secrets on Vault. So let's bind it to the service broker. So in this example, they are creating a separate space, and in my demo, that's how I'm going to do as well, and shifting the target to this space. Next, you have to formally create the service broker. And here we're passing this flag space scope. So whenever you deploy a service broker in PCF, there are 3 different ways that you can do it. You can either deploy as a global service broker, so it's available to any app. You can deploy as a space scope, like it's done here, or you can deploy as organization scope. It's going to depend, once again, to your organization's workflows and policies. If you do a CF marketplace, it's going to show you that now it's available as a service to be consumed. And in this case, their app is called My App, and the Vault service broker is called My Vault. So this is the moment where it's binding the service broker to the app. So in that example was this moment. So this is what we have done so far, is just to push the service broker and configure it, make it available to be bound to the app. PCF has this very interesting feature that whenever you make any changes to the app configuration, you have to restage it or stop and restart. So once you bind the service broker immediately is going to inject those values in the environment variables, but until you restage the app, it's not going to pick up those changes. So you're going to restage, and then you can verify the environment variables available for the app, and it's going to show you this. What this means is we have the Vault URL here, we have the token here, and these are the 4 secret paths that are available. This one is the one that's specific for the app, so this is the app ID, and this is the app ID for the secrets and for the encryption key. And this is for the shared secrets in the organization and in the space. So you might look at this and it's like, okay, Stanley, this is in the environment variable, but this looks ugly. Am I supposed to, should I expect my developers to type all of this to retrieve the secrets? And the answer is no. So they're exposed as environment variables, but through these names here as a JSON parameter. So I'm going to show what it looks like in the app. You don't have to specify this. You can abstract those values. It's more human readable. So this explains about the 4 different backends. Before going to the demo, I just want to cover what are the service broker permissions that are required in Vault. So a Vault admin or somebody with elevated permission needs to go to Vault, create that policy, and then generate that token to be injected in the service token. So what this policy does is admin capabilities. So for example, it allows you to list the mounted secrets available, to create new child policies with this CF name, to create new tokens and generate tokens. So this is what's going to give the service broker elevated permissions to dynamically bootstrap the new apps deployed on PCF. And that's pretty much it. So this is the PCF. And you can see here that I have my service broker is already deployed, and in the settings, where the user provided variables. So this is where the vault address, vault token, and the username and password were inserted. And this is my example app. And you should see in the settings, it's the same environment variables that we saw before. So this is my actual vault for this example, the token for this vault, and the different backends. So what I want to show is this. So on HashiCorp guides, we have the Spring Cloud Vault. Right now is in this particular branch, but it's a pull request. By the time that somebody's watching this recorded webinar, it should be available. But let's go through. So this is the POM XML that I spoke about. This is just the libraries, the dependencies that you're importing, nothing too exciting. On resources, this is application.yaml. So this is the application information, like which port is listening, some driver information. This is mostly Spring Boot. But for the PCF Service Broker, this is the secret sauce. You're using these environment variables, so you're abstracting the value itself. And this is what I mentioned about being human readable. So what this is pointing to is this environment variable, the generic one. So VCAP services, credentials, backends generic is what you can see here. And the same thing for the backend shared organization. So what you can see here is that even though the service broker has injected all these environment variables, there's these 4 backends that are available. For my particular app in this demo, I'm only using this, the generic and the organization for the ones available from the service broker. And then if we have time, I'm going to go over a few additional features that this app has. But for now, let's just focus on static secrets that are going to be in this generic backend. Another important thing to note is the Spring Boot Vault is going to look for the secret that's under whatever you list in the application name here. So that's a very opinionated framework. That's the way that they have done. But I'll show you how it works. So we have our app here, and this is the app URL, persistent Spring here. So it's what I have open here. And in this particular app, we have defined this endpoint, API secrets. Let me show you what it looks like here. Oops, not this one. Secret controller. So this is where I define the /API secret. And what I'm doing here, the way that this very opinionated Spring Cloud Vault framework works is whenever the app starts, it's going to look for in the Bootstrap TMO. It is going to look at the backends that are available here, so the generic and these shared backends. It's going to look for these two keys, and then it's going to make it available to the app. And then in the app, whenever it sees the @ symbol like this, it's going to try to find this secret key in whatever is available. And if it finds, it's going to list as this secret variable. Otherwise, it's going to list the value NA. So if we hit this endpoint, and this is a get, yeah, the default is get. So if we hit this endpoint, right now there's this value test. I have my Vault UI open here very conveniently. Let me just make sure that I have the right. So in the Vault UI, this is what the Vault Service Broker has created, those mount endpoints. So if we look here, we are looking for 5A640. 5A640, this guy. So right now it's test. We're going to edit. Test. Save. And if we go here, oh wait, it didn't work. So once again, it goes to the Pivotal Cloud Foundry. It doesn't change anything until you stage the app. The cool thing is my colleague, Lance Larson, is smart enough to have identified, what's the name of the thing? There's a way of refreshing the app without having to actually stop and restart. And it is described here in the name, the actuator. So it's a library, it's a Spring Boot library. So you can do, I'm going to do on the terminal because this is a post. You could use Postman, but it wouldn't work on the browser. So if you just hit this endpoint actuator refresh, it's going to work. Don't worry, I'll change the URL. It needs to be the correct URL. So if this worked, yeah, so great, it worked. This shows it's a new test. So before I move forward, I just want to recap everything that I have covered to make sure that it's solid. In summary, what I have shown is a demo where you have an application that's retrieving a static secret from Vault. And this application is using the Vault Service Broker. So this is my application and the Service Broker. I have explained how to configure the Service Broker, just following the commands on the Service Broker GitHub page. And then I have explained that once you bind the Service Broker to an app, the Service Broker is going to create those policies on Vault in the background and generate a token and inject those values inside the Bootstrap as an environment variable available to the app. These environment variables available to the app. And the app, if the app is using Vault Spring Boot framework, you can rely on this Bootstrap TMO to retrieve those environment variables and make them available for the app to consume. So once you have declared something like this, along these lines in the Bootstrap TMO, and the app starts, it's going to make whatever secrets are here available to be consumed by the app, and the secrets are consumed using the @ symbol. So it's very simple. It can be deceivingly simple because, but it's all about implicit. The configuration takes precedence. So that's about the static secrets. And if you're somebody that doesn't have a lot of experience with Vault, with PCF, feel satisfied with this. And my suggestion is go to GitHub, download the repository, and play around. But now we still have a few minutes before we break for questions. I want to show another cool feature of Vault, two cool features. One is that Vault can go to a database and dynamically create credentials to be given to an app. So you don't have to manage static database credentials. And what's dynamic is the creation process and also the fact that these credentials have a time to live. So after this specified time to live, they're going to expire and automatically are removed. And the other thing, I'm going to show an example using the encryption key. How an app can ask Vault to encrypt a string, and it can then store in the database encrypted. So for this example, it helps to have an understanding of how this dynamic database credential works. So I feel that this diagram is valuable in that sense. So if you have a Vault admin to the left, and you want to take advantage of this service, there are 3 things that the Vault admin must do. First, it needs to enable, well, 4 things. It needs to enable the database secret engine in Vault. Second, it needs to give Vault a connection string. So the connection string should access database with username and password, and that's going to be used by Vault to create these users. Next, the admin is going to give Vault a SQL query with the user creation command. And that's where in the SQL query is going to be specified that particular user, which tables you will have access to read, write, whatever. And finally, an associated time to live for this user. The default, I believe, is 1 day, but you can change that as you wish. And you can have multiple configurations, so you can communicate with different databases, and you can also have multiple SQL query types. So if you have an app that needs greater permissions inside a database, it can use a certain query, which is going to be associated to a row, or you can use a different one for lesser permissions. So once Vault is configured, this service is available. And a client that has permission to use the service to request credentials can request it from Vault. And then Vault is going to take this connection string and execute the SQL query in the database. And that's going to generate a username and password. Vault then gives this username and password to the client, which can then use for connecting. And once the TTL expires, Vault is responsible for deleting that user, so the app or a DBA don't have to worry about that. And Vault also has some security features that make it very easy to revoke these dynamic users. So you can revoke all of them, a group of them, there are a variety. So what this looks like in our demo, we have here this order API controller. So instead of /API secrets, it's /API orders. And there's going to be a post and a get command. The post is where it's going to save, write something to the database, and the get is going to retrieve. So if we do this, it's going to be a bunch. It's reading. And I can show you on the database. So this is the table that we are going to be communicating with. It's called the table orders. And like I said, this is a double example. It's not only the dynamic credentials, but it's also the encryption keys. So this is how an encrypted string is stored. And if this works, once it returns, it's going to be in plain text. So Vault is able to decrypt. We see an error. I don't know what happened, but the other thing that I want to show is these are the users that Vault dynamically creates. So I'm filling bold here, and I'm going to revoke all the users and ask Vault to create again. So this is the command. And this is a safety feature. So if you're a Vault admin and you find out that a certain set of database credentials have been compromised, if they were dynamically generated by Vault, you can do something like this. And this is going to revoke the credential. But I need to be at the correct, this one. Well, normally it would work. If I have time, I'm going to try to find out what happened here. But just assume that you could delete this, and then once the application starts, it's going to retrieve database. So how does the application is asking Vault to generate these new credentials? This logic is actually here. So this Vault demo order service application.java is the first class that is executed once this application starts. And once this happens, it's going to, in a similar fashion to the static secret, is going to use this @ symbol and try to retrieve this value from the Spring Vault environment. And if it finds something, it's going to associate it with the user and it's going to associate it with the pass. How this is defined, this is what you can see here on the Bootstrap TMO. That we specify that the Vault backend that has the services called database and the role that it wants to request is order. Role is the SQL query that's going to generate the user. That's how it's registered inside Vault. It's called a different role. And in this particular case, it's the role order. And one last thing that I described in the README is that these two examples of the dynamic database credentials and the transit backend, they go beyond what's available by default on the Vault PCF Service Broker. So what I had to do to make this work is I had to, like I mentioned, these are additional paths that I want to make available for my app. So once the policy was created, I went to Vault and I manually updated the policy to include these three paths. So this particular one gives permission to whatever entities associated with this to read, to generate a new database credentials. And this is because I wanted to use a more generic, general encryption key and not the app encryption key. So I want to leave some time for questions, and I think that's going to be more interesting than me trying to debug and figure out what went wrong here. So I think now would be a good time for questions. What do you think, Amanda?
Yeah, that sounds great, Sanyo. Thanks. That was a great demo. So we have one question so far, and if anyone else has questions, please go ahead and type them into the terminal, and we will get them answered for you. So, Sanyo, someone's asking, other than the basic authentication with token, does the solution support any other authentication mechanisms, such as like app role, response wrapping with Cubbyhole, or AWS IAM?
Right. Out of the box, the Vault PCF broker only supports token, but it would be a situation where you should customize the code. And this would be the code like on the Vault Service Broker. So the short answer is that Vault Service Broker is giving you convenience for this specific, very specific opinionated use case. Whenever you're expanding, you want to use additional authentication methods or other secret engines, you're going to have to customize the code.
Hey, Sanyo, this is Lance. Do you mind giving that API one more try? I ended up restarting that application, and I think we're good to go here.
Oh, yes. Is it the thing that it expired, the token? Like that issue that I had before?
It's possible. I'm going to assume that was it. But yeah, you should be good for all those API calls now.
Yeah, so going back to the database demo, this is what I wanted to demonstrate, is that the code on Vault is encrypted, so for customer name, but here it shows decrypted. And the place where this decryption is happening is here. So this is the order object that represents what's stored in the database, and we're just calling this transit converter and the convert. So using the magic of Spring boot, it's able to automatically place the converted string where it's needed. And this is because it's following the standards. That's one of the reasons why we were using the more generic transit key, the encryption key backend, to make it simpler for the demo. Thank you, Lance.
Thank you, Lance. Thanks, Daniel. Okay, next question, Daniel. So someone's wondering, can we use this broker on others than PCF platforms, so such as AWS or on-prem?
No, unfortunately, this broker is only for PCF. And that's because it relies on certain bindings and this whole service broker approach of PCF.
Great. Okay, thanks for the clarification. So now someone else is wondering if there's a plan to make the service broker as a service in PCF, such as a config server or Redis.
I'm not aware of any plans like that. So this is available for the community. If anybody has a strong desire to take this somewhere else, we welcome pull requests and volunteering efforts to improve it.
Great. Okay, thank you. And then next question. So someone's asking, how can we use the certificate to authorize a user from PCF instead of using username or token?
How can I use a certificate from PCF instead of using username token? That's a great question. So right now, the way that the service broker exists, it's using those methods. If you want to use something different, you will need to customize it. It's not available.
Okay, and then the next question. So someone's saying, it seems that the database or the LDAP services administrators act as admins in Vault and generate keys for the client applications to connect to these systems. The client application itself needs to connect to Vault. So then they're wondering, how would the client store the credentials to connect to Vault? And let me know if you need me to repeat that.
No, I think I got it. So let me go back to the diagram here. So in this particular diagram, what's required is for a Vault admin to create the service broker policy and generate a token associated with that policy. So that's the responsibility of a Vault admin or some PCF manager, somebody that has elevated permission and has access to Vault that allows them to create this particular elevated policy and token. So once this is created, they're going to configure this in the service broker. And this policy has enough permissions that it allows the service broker to create child policies, so policies for each one of the apps, and the tokens for these apps. And the service broker injects those in the app. So if you're asking how the app is going to manage the way to communicate with Vault, those are available as environment variables for the app. So if you're concerned who will have access to that, whoever is able to get to this, so this is the app, the settings, whoever has access to this screen that they can show the environment variables, they will see the app. But otherwise, it's in the PCF environment variables available to be consumed by the app. And in this example here, I show how one example of how an app can consume that by referencing the environment variables.
Okay, great. And then it looks like we have one last question, Daniel, unless anyone else wants to quick drop theirs in. So someone's asking if can Spring Cloud Vault work independently from the service broker?
Yes. So as I mentioned, I think it's good to go back to the service broker limitations. The only thing that the service broker is doing is creating these policies dynamically and generating the tokens and adding that to the app. But if you have a workflow where your developers open a ticket and there's a Vault admin that creates those policies and generates those apps those tokens to give to the app, or if your developers even have enough permissions to do it by themselves on Vault, then sure, you can use an app in PCF without using the service broker. Then it would be, instead of having this convenience, you would go to just this, and somebody would be responsible for entering those values.
Great. Okay, thank you. So, Daniel, I think that wraps up our questions. So those were some great questions from the audience. Thank you, everyone, for your participation. And I hope everyone enjoyed today's webinar and you were able to learn a bit more about Vault and the Cloud Foundry Vault Service Broker. A special thank you to Daniel for his time today. And I also want to mention our next Solutions Engineering webinar is also going to be on Vault. It's going to be on Friday, May 4th, just about 2 weeks from today. And our team member, Jake Lundberg, will talk about streamlining certificate management with Vault. I'll include the registration link to that in our follow-up email to you that will go out with the recording today. And finally, as I mentioned, this webinar was recorded, and we will make the recording available on our website after processing. And again, it will be in that email that will go out to everyone who registered. You can also keep your eyes out on Twitter. I'll post the recording link a little later today. So thank you, everyone. Goodbye. Have a great day.
Thank you.